All right. Welcome to
See the waves.
Algebra 2. It's Tuesday, May 5th, Cinco de Mayo Day. Let me go over a few things. I've graded the 6-4 quiz from last week. I have no quiz from the following people. Mr. Baird, and I just checked the Dropbox, nothing's in there. Mr. Daughtry, Mr. Griffin, Mr. Guire, Mr. Jenkins, and Mr. Belize. Submit that. You're going to lose points for being extremely late, but it's gonna be better than
Wait,
zero.
sir, the 6-4 quiz, I emailed that to you.
Why didn't you put it in Dropbox?
Because you remember you told us not to put it in Dropbox one time because, like, you weren't.
Oh,
Use Dropbox for stuff.
tell him, Jaden.
If it's extremely late, then email it to me. So go ahead and re-email it. Go ahead and email it to me since I'm not going to go back in Dropbox. It was in Dropbox and it wasn't in there. So
mine must have not submitted. I can resubmit mine to Dropbox.
all right. Any questions on the 6-4 quiz? I'll have them in Blackbot. I thought I'd put them in there, but I'll have them in there probably within 20 minutes of the class ending.
What's up, tutors?
Okay. Questions on the 6-4 quiz? All right. Other announcements. We're down to, after today, I'll only have you guys 5 more classes. 5 more
Yeah.
kids, okay? There's a lot of you that have a lot of zeros. Some of it may not be your fault.
You washing his hands.
All right. Some of it, I've got a stack of probably 20 to even 22, 23 problem sets and quizzes with no names on them. So the next couple days, I strongly encourage you, if your grade is lower than what you expected or anticipated, is to go back into Blackbot and see what's missing. You may have it sitting there on your desk or in your notebook. If you do, email me what you are missing so that I can get that in there. I promise you, I can guarantee you, it's recorded that I am not going to be taking a bunch of late work after this week. All right? It's on recording. I'm not going to take late work the last 2 weeks of classes, and next week and the following week are the last 2 weeks of classes. So this is the week for you right now, between now and Thursday, is to go back and see if you're missing anything. Again, you may think you're not because you submitted everything, but if you submitted something with no name on it, and there's a couple of you that have very distinguished writing that I can figure out, but most people don't. So like I said, I've got probably 20-some quizzes and classwork homework assignments over there with no names. Questions or comments on that? Be good? If that was Mr. Curzon, it came back real stuttered, or whoever that was that talked. I couldn't grasp any of that.
I didn't talk, so.
Okay. All right. Okay, so today we are going to jump into the next section, which is 6.5, which is operations with radical expressions, which is more things under the radical, but it gets it's similar to what the last 2 sections that we've had, but the complexity is ramped up another notch. So we're going to, hopefully you've got pretty good foundation from the last 2 sections because this one has, it is more complex. So I'm going to share my screen. As soon as, I should have put this in before class, but I didn't. So just take some loose leaf paper and make some notes and then add them to this problem set. And if you don't have a printer, you can, you're going to see the problem set, and it's only, we're going to have quite a bit of discussion. I'm going to go over a couple of examples, and it's only 6 problems, and collectively we're going to work 1, 3, and 5, and then you're going to do 2, 4, and 6 for homework before class on Thursday. All right. Let me do a couple of things here. Let me Increase the size of this. All right, everybody see my screen all right? Problem set? Yes? I take that
Yes,
as a yes.
Suki, we can see it.
Okay. All right. Shoot. Let me undo something here real quick. All right, so here we go. So I'm going to talk about some properties. You've already used some of them. Some of them we've discussed in one way, shape, or form. This is kind of a precursor to actually start doing some of these properties, and just so that we have a understanding of what
Wait, sir. Can
that
I
we're
say,
applying that helps us to simplify these problems with radicals. Audrey, say again.
I have the quiz right here, sir. Do you want me to send it to you again?
No, I'll drive over and pick it up at your house and grade it for you.
I'll leave it on the door.
Sir.
Yeah, just leave it on the front doorstep.
Sir.
All right. Okay, so let's go over these properties of radicals, okay? For any real numbers, A and B, n is greater than 1, which means we're going to be we're not going to deal with negative radicals. We may get to that before the year's open, but the n is always going to be positive. So we're going to do square roots, cube roots, fourth roots, fifth roots, sixth roots. That's all that's saying. No big deal there. That makes your life and my life easier, all right? So if n is even, 2, 4, 6, 8, 10, 12, right? And A and B are both non-negative, which is really stupid way of saying it, which let's scratch out non-negative, because let's just say non-negative means positive, all right? So let's just say positive. Then we can rewrite this thing as this, all right? So let's just say an example would be, I'm trying to think of a good example. But that's saying, let's just say if you had 2 and you had 4 times 5, right? You can rewrite that as just 4 under the radical times 5 under the radical. That's all that's saying. That's kind of common sense, makes sense. But by changing the format to this, oftentimes you'll see stuff that you didn't see written like this, and it makes it easier to simplify. Okay? Now, if n is odd, meaning we're taking third roots, fifth roots, seventh roots, ninth roots, and so on, it's the same kind of deal. So I'm not gonna rewrite that. Everybody good so far? All right, Mr. Cohn's thirsty. All right. All right. Have you heard this term before, and do you know what it means? What is a radicand? Radical is that guy, right? What's the radicand? The radicand is whatever's under the radical. That's what the radicand is. Okay? So if you see that term again, that's what they're talking about. Okay? And what this is saying is stuff that we did in a previous section, 6, 8, 10, 12 weeks ago, when I gave you that little kind of 3x5 kind of cheat sheet where we were pulling perfect squares out from under the radical. If it wasn't a perfect square, it stayed underneath it. All right? So we've done a little bit of this. It's just going to be a little more complex this go around. All right, it says use the product property to isolate perfect squares. What does that mean? Anybody? All right. Sometimes we use fancy words and big words to make it sound really nifty, gee whiz. All right, so all that's saying is let's use that example from where we had 4 times 5. Let's say you're given that problem there to solve. Square root of 20, or not to solve, but to simplify. All right, well, the product, what's product? Product means you're going to multiply something, right? So we already know 4 times 5 is 20, or we could factor out, if this is an even number, we could start factoring out 2. So if I can change 20 into 2 times 10, right? I can change 10. I can factor out another 2 out of 10. I go 2 times 5, right? So if we're doing square roots, here's a perfect square. I got 2 times 2 times 5 is 20, right? So I can bring 2 out from under the radical, and I can leave 5 under the radical. That's what that property is saying, and that's what it allows you to do. All right. And we're going to simplify. We're not really solving. We're simplifying. And when we say simplify, all we're doing is we're going to pull as many perfect squares out front of the radical as that we absolutely can. Good so far? Any questions before I move on? I said some of this is review. I said it's just going to get a little more technical, a little more advanced than what we've had up to this point. All right. You actually had one of these in your quiz, okay? And let's see here. I think, if I remember the problem correctly, I think it was 25. Sorry about that. Someone's breaking into my room. Don't know what the deal is there. All right, we can rewrite. I think that was on the quiz. We can actually rewrite that similar to the examples above. We can put 25 under the radical over 36 under the radical, right? And sometimes if we write it this way, you'll see stuff that you didn't originally see. So the square root of 25 can come out from under the radical as 5, and the 36 can come out as 6. That make sense? Any good so far? All right. Hearing no whining and complaining, we'll move on. Okay. All right. So let's look at the example. We're taking the cube root of -16, a to the 5th, b to the 7th. So let's just work left to right. All right. So we know this works out fine because we can bring negatives out from under the radical when the root is an odd number. So that negative is going to come out from under the radical just as written. All right. So I'm going to do it a little differently from what the example said. So if I've got 16, all right, even number, let's see what I can factor out of that. So I'm going to just start by factoring 2's out of that. So I can factor a 2 times 8, right? And that is an 8. And then out of 8, I can go 2 times 4, right? Let's see, is that right? And then I can go 2 times 2. All right. Let's see here. What else can I do? Oh, we're doing cube roots. I had a momentarily brain fart there. Okay, so look what we got. We got 3 2's right here. We're doing cube roots, right? So those 3 2's are going to come out as a 2, right? And now I still got a 2 left under the radical. This 2 right here, right? Are we good so far? Yes? Or is everybody sleeping? Or watching a view? Okay. All right, so now let's look at,
Oh, sir.
let's look at a to the 5th, all right? So why can't I rewrite, kind of like we did up here, can I rewrite a to the 5th as a cubed times a squared?
So, may I use the restroom?
Yes,
Thank you, sir.
at your house.
So what a kind
Yes,
gentleman.
sir, I will.
Okay. All right, so does everybody, do I need to write that? Can you see this over here? To the left where I'm writing?
Yes, sir.
Okay, so I remember when we have like bases with radicals, we add the exponents. So a to the 5th, an equivalency to a to the 5th is a cubed. And why did I pick a cubed? Is because we're doing cube roots. And it's times a squared, right? 3 plus 2 is 5. Are you good? Like I said, you've done some of this before. So the a cubed, I can take out the cube root of a cubed is a, right? And I still got an a squared under the radical. Good so far? Holler for lost in the sauce. All right, now let's look at b to the 7th.
Good, sir.
So b to the 7th, if I kind of treat it similarly as a to the 5th, how many b cubes do I have in there? I got b cubed times b cubed times b, right? So b cubed comes out as b. This b cubed comes out as b. So now I've got b times b, or b squared. And I got a b still left under the radical. Bada bing, bada boom, I'm done. Does that make sense?
Yes.
All right. Okay, so let me, hopefully you've got some loose leaf paper there. There's only 6 problems on this problem set. Collectively, we're gonna do 1, 3, and 5. And then you're gonna do 2, 4, and 6. All right. So let me, let's look at number 1. Are we ready? All right, so we already have 5 outside the radical, right? So we're just gonna let that ride. Now, we got 54 in there, all right? Kind of an odd number. You might recognize that that's 9 times 6 is 54. And 9, if we hear or see 9, bells and buzzers start going off because 9's is equivalent to 3 squared. Let's say we didn't see that. So since it ends in an even number, I'm going to start factoring out 2's. If it had ended in an odd number, I'd probably start factoring out 3's. So if I factor 2 out of 54, that's the same as 2 times 27, right? Now I've got an odd number, all right? So I know 27, because we've used that a lot. I can factor a 3 out of that, and that's 3 times 9, right? And then 9's a perfect square. I factor another 3 out of that, so I got 3 times 3, all right? So how many perfect squares do I have in there? All right, I've got this, right? So now I can bring that 3 times 3, or 3 squared, out of the radical as 3, right? So now I've got 5 times 3, right? Which is 15. And this is where I got the 5. And the 3 is the 9 I pulled out, the perfect square I pulled out from under the radical. What do I still have left under the radical? What's still left? I still got a 2, and I still got a 3, right? So I got 15 radical 6, or 15 square root of 6, and we're done. And that would be your final answer that I'm looking for. Questions, comments, concerns, conjecture,
No.
complaints? Make sense?
Yes.
Looks like the 2 deer at Nick's house are nodding their head up and down, so they must be getting it. All right.
Sook.
All right. Okay. Next one. All right. Are we ready? We're doing 1, 3, and 5. You're going to do 2, 4, and 6. All right. So if there's nothing right here, it's always square root, right? Okay. So remember in that previous problem and also in the example, I didn't know what perfect squares were in, what was that number, 54? All right. So likewise, I've got 75 here. So if the number ends in 5 or 0, I'm going to kind of take a little bit of a shot in the dark, and I'm going to start factoring 5's out of there. So if I factor 5 out of there, or if you recognize, hey, that thing's divisible by 25, and 25 is a perfect square, I could divide 25 in there. I got 25 times 3. Or I could just factor 2 5's out if I didn't see that. All right. We love 25 because that's a perfect square. Mr. Johnson's back. All right. So,
Yes, sir. I've returned.
so we love that. So we're going to pull that 25 out from under the radical because the square root of 25 is 5. Okay. And we got 3 left over. Good so far?
Yep.
Now, so we took care of that. So now I've got x to the 4th, right? Well, x to the 4th, when I start simplifying things, I can rewrite as x squared times x squared, right? So it's x squared times x squared, or we could do it this way, right? Another way we could look at this is x squared to the 2nd power. So that x to the 4th can come out from under the radical as what? What would I write here? X what? X to the what power? Anybody? Anybody? Participatory learning?
X to the 4th power.
It's x to the, what I'm doing is I'm taking the square root of x to the 4th. If we just look at this one component individually, right? So the square root of x to the 4th is x squared, right? You good?
Yeah.
All right. So the only thing I got left is the y, right? So I got y to the 7th. And again, there's a couple different ways to approach it, right? Let's see what perfect squares we got y to the 7th. Why don't I take that y to the 7th is the same thing as y cubed times y cubed, or y cubed squared times y, right? So the square root, because it's 3 times 2 is 6, plus the 1 here is 7. So I just rewrote it. I didn't change anything. Y cubed to the 2nd power times y is the same as y 7th, right? I'm just kind of breaking it down into components that I can then pull out from underneath the radical. So the y cubed squared is going to come out, if I take the square root of it, it's just going to come out as y cubed, right? And I'm going to have a y left under the radical. And my final answer is going to be that. Let me just double check, make sure I didn't leave anything out. Yep, that looks good. Any confusion, anything I need to clarify? All right. Hearing none. Last one. And I'm going to turn it over to you guys. I'll let you copy the problems off the loose leaf, or you can wait till I post it in black body and you can copy them there. All right, so here we go. Let's just let's change things up just for reference. Okay. Now, what we may want to do is to rewrite this like we talked about in the kind of preliminary discussion. I could put a to the 6th or b cubed over 98. Okay. Same thing. And if we break it up into kind of little chunks or pieces, that may make it easier to solve. All right, so I'm just going to start on the bottom just because we're here. All right, it ends in an even number, so I'm going to factor out a 2. 2 goes into 98, goes 49 times. All right, any bells and buzzers going off? Yes, no, maybe so. I would think 49 is what? 49 is a perfect square of 7. All right, so on the bottom, I can simplify the square root of 98 as 7 outside the radical and then the square root of 2. Does everybody agree the square root of 98 is equivalent to 7 radical 2? That makes sense? Okay. All right. So that takes care of the bottom for the moment, because I failed to mention when I was on the side 1 there about no radicals in the denominator, but we'll address that here after we take care of the top. All right. So now let's look at a to the 6th, right? We're doing square roots because there's nothing here, right? So a to the sixth is equivalent to what? I can rewrite that as a cubed times a cubed, or a cubed squared, right? So that whole thing can come out from another radical as a to the third power. Agree? And then the b cubed is equivalent to b squared times b, right? Because b to the second power times b to the first power equals b cubed, because it's 2 plus 1. So now the b squared can come out from under the radical as b, and I still got a b under the radical. Okay, I'm not going to scroll up, but I will after I finish this problem. And that second example on side one, and I'll go back to it and kind of walk you through some of the key points of that here in just a minute. And something I failed to mention in kind of my preliminary discussions and introducing the lesson is that remember back about 8 weeks ago when we talked about complex conjugates, all right? And we had some scenarios where we had radicals in the denominator, meaning that they're the lower part of the fraction. And in those situations, we couldn't, to simplify, you could not have any radicals in the denominator. So how do we address that? Before, we would take whatever that complex conjugate was and we would change the sign of it and fix it that way. And I think that we were doing that when we were doing imaginary complex numbers. Slight different variation here, right? So the way to get rid of, or does anybody want to take a guess? How can I undo or simplify that square root of 2 in the denominator? How can I fix that or address that? How about, don't all speak at once, but let's talk.
He said, "Don't speak it."
We heard him, Eddie.
I don't know why I
Okay,
said that.
Cinco de Mayo. All right, if I had radical 6,
What spells Cinco de Mayo?
what happens? What happens? What happens? Where's Amanda Sparza when we need her? All right,
Sir's
what
weak.
radical 6 times radical 6? What does that equal?
What is the equal, Mr. Daughtry?
36.
36, are you sure?
No. Wait, sir. What did you say?
What is that? What does this equal?
9.
No, where'd you get that?
Because you got, wait, no, it's not, though. Hold on.
Radical
So
6 times radical 6. Square root of 6 times square root of 6.
the square root of 6, there is no square root of 6.
Would you be surprised if I say that equals this?
6.
Anything under the
Sure.
radical, any square root under the radical times itself is going to equal itself. Just like if I did this, if I did if I had 123 under the radical, if I multiply that times 123 under the radical, and then this is talking strictly square roots, it would equal 123, right? I just did 123 just because it was 1, 2, 3.
Yeah.
All right. So as long as we kind of have an understanding of that, the way I fix this is I multiply the numerator and the denominator by that radical that's in the denominator. All right, so we watching? So if I multiply radical 2 times radical 2, what do I get? Oh, too many talking at one time. I couldn't hear.
2.
2. All right, so what's 2 times 7?
Burrito.
14.
14. Okay.
Did you
So-
get that, Mr. Jackson?
Now on the top,
Yes, I did, Mr. Dodger.
we multiply the radicals times the radicals. So we still have the a cubed, the b, and now we have poetry. We got b or not to be. All right, so it's 2b. So that's my final answer. Right, Mr. Cohn?
what the Suki?
Does everybody see that?
Oh, Coach Burrito.
What's that split?
Coach.
You all right? All right. Let me do something. Okay.
Sir, do you have that split?
I have the what?
It's that split.
Split.
I have the what?
Okay. I didn't go over this example earlier, and that's this is an example where they ended up with, and I'm not going to walk y'all through it. I'm not going to get hung up on the absolute values. I'll let you worry about that when you get to pre-cal next year. All right. But you can see they simplified it and they had a 5y under the radical. So similarly as to how we solved number, what was that, 5 on the backside, we multiplied the numerator and denominator by that radical there that's in the denominator. And you can see what happens. The square root of 5y times the square root of 5y equals 5y, all right? And then we multiplied the 5y times the 3y squared, which gave us the 15y cubed. Pretty complex problem. You can do this, you got it made in the shade. So, if you got a pencil and paper handy, hopefully you made some notes of what we talked about the last 35 minutes and those 3 problems we did. I'm going to give you a couple of watch out for us to be careful of on these other 3 problems that you're going to do for Thursday. Okay? So let's look at this first one. I'm going to just kind of give you, I'm not going to work it out for you. I'm going to give you some watch out for us. All right? Okay, we're not doing square roots. We're doing the fourth.
Hey, you got your pen and paper.
We're doing fourth roots, right? So start factoring out 2's and you go from there, all right? Change that a to the 9th into how many a to the 4ths I got in there. So I got a to the 4th times a to the something times a to the something, right? And then do the same here. Why am I doing it in 4ths? Because an a to the 4th is going to come out to the for the 4th root, it's going to come out from under the radical as a, right? Let me just elaborate on that. Let's see, let's do this here. If I'm taking the 4th root, let's just say t to the 4th. What's the 4th root of t to the 4th equal? Anybody? Any of the Mr. Johnsons?
Sure, what's the question?
What's the 4th root of t to the 4th? Right here.
The
What's
4th root of,
75.
75.
yeah, 75.
Where'd we get that?
I don't know, sir. I was just saying it because he said it.
Sir, legend has it is 75. Oh. Sir.
The 4th root of t to the 4th equals t.
Oh, that makes sense.
All right. So think in those terms. Just like b to the 20th, I'm going to see how many b to the 4ths I got in there. I got 1, and then I'm going to let you keep going. And there may be 3, 4, 5. You're going to figure that out. All right. I'm just giving you some pointers and watch out for us and some things to consider, factor, and solve these. Anything on number 2? So I'm not going to work it out. You're going to do that. So write that problem down if you haven't already, or wait till I put it on Blackboard here and print it out. Okay, I'm going to scroll the page up. It might be still on the page. All right. Yeah, it's still, I'll leave that there in case you want to copy. All right, this guy here. I think it would help if you don't see ways to solve it. I think it would help if you kind of make 2 smaller problems out of 1 big problem, and then go from there. And I already did something similar to this earlier today. and then go from there. We're doing square roots, so it's nothing that complex. That's number 4. You're gonna do 2 and number 4. All right?
You got it, Mr. Wolford?
Let's scroll up again. All right. Ah, shoot. Maybe I can see it a little bit higher. All right, this guy here. Okay, the be careful ofs, all right? There's a cube, we're doing cube roots, so don't think in terms of cube, don't think in terms of square. Again, I would probably break this up into 2 smaller problems, all right? Now, since 40 is an even number, I think I'm gonna start by factoring out 2s, and hopefully I can get 3 2s factored out of there. But I'm gonna leave that up to you to figure out. P to the 5th is P to the 3rd times what? Another way to rewrite that. P to the 3rd times what? Anybody? Bueller? Bueller? Bueller?
Say that again.
What's another way I can express P to the 5th? What's an equivalent to P to the 5th? Thinking in terms of doing cube roots.
P to the 5th.
Bueller?
Sir.
P to the 5th.
Draw a burrito.
P to the 5th can be rewritten as P cubed. I just went over all this. You guys,
P to the 4th.
P to the cube times P squared,
Sir.
right? We're taking cube roots so that P cubed is going to come out from under the radical as what?
Sir, doesn't 3 plus 2 equal 6?
3 times 2 equals 6. 3,
Sir, it's 3 plus 2.
3 plus 2 last time I checked equals 5.
Sir, that's not true.
Oh, okay.
Sir, you gotta prove that.
Good
Yeah,
job,
that's not true.
Suki.
Code, doesn't 3 plus 2 equal 6?
Yeah.
Sir, it says it right there. You just. That's
Sir,
right.
3 plus
That's
2
right.
equals 6.
Sir, I'm pretty sure. Like,
Sir, look it up on the internet. Come back to us. Okay?
Sir, 3 plus 2 equals 6.
Well, I guess I'll see you next year in Algebra 2.
Yes.
Or then,
more burrito action. Sir, 3 plus 2 equals 6.
okay. So let me ask you this. Let's say if I had R to the 3rd. Tell me what this equals. The cubed root of R to the 3rd equals what? You've got-
R.
this is
Eddie, I don't
basic.
see any camera.
You've got to know this. It equals R,
Sir.
right? Let's do this.
Oh, computer broke. You know how that
What's
goes.
the burrito?
If I had R to the 6th, the cube root of R to the 6th,
Boston burrito going down my Speedo.
what's that equal?
Hope you can
R
understand.
cubed.
Say again?
R cubed. R squared.
R squared, because it's R cubed times R cubed. Or R,
Do that noise again. Like the
so that equals R squared, all right? Coming down the eye, you're missing the problem.
Sure, looks cute.
Sir,
Okay.
no.
All right. So I gave you enough information to solve this. What can I review or go over?
2K, Madden.
What can I clear up? Any confusion? What can I clear up? Let me scroll back through. Okay, so you're going to do. You should hopefully you made some notes on 1, 3, and 5. You're going to do 2, 4, and 6. Okay. I will load this on Blackboard a little bit after class ends, no later than 2:30. If you've got a printer, I'd print the whole thing out because there is a wealth of good information here. And the examples aren't too shabby.
Suki, love you.
Okay. What's a radicand?
It's the number under the radical.
There we go. Thank you. Is that Mr. Daughtry or who was that?
I feel.
Mr. Haifa.
Thank you.
Sir, no, it wasn't. It was me.
At least 1 out of 22 is paying
Oh, I
attention.
said that.
Okay.
Thursday night.
The Vatican is what's underneath the radical, right? Think about rewriting these things in simpler terms where you kind of break it up into pieces that may make it easier to solve. Okay? Kind of do it in chunks or smaller pieces. All right? Remember, do not give me any answer with a radical and the denominator. We know how to fix that. You multiply with numerator and denominator by what is ever under the radical in the denominator. Okay? Remember that. I think that's a pretty decent review. All right? Anything else I need to go over?
Good job today, sir.
Okay. First, we're going to up the complexity. So we'll make sure we got a basic understanding of this. This is more complex, but it's applying the same rules and properties of radicals and exponents that we've dealt with probably over the last 3 weeks. So if you struggle with some of the stuff in the last few weeks, this is going to be harder just because the complexity's been upped. Mr. Valise, who is not here, Jenkins not here, but Dwyer, Griffin, Daughtry, Baird, make sure you give me that quiz. I'll repeat one more time so it's on multiple phases of this recording.
Sir, can you check your email? I sent it to you like a couple minutes ago.
This is the last week I'm taking late work. So the zeros are going to ride, but you need to go back and check your Blackbaud grades because you may be sitting there fat, dumb, and happy that you've submitted everything.
Sir.
You have, but if you didn't, I kind of like, what was that from Animal House?
Oh.
Stupid or something? What was it when Dean Wormer was talking to him? Anyway, not to get off the subject.
Sir, telling random stories.
Because you may think that you've submitted everything and maybe
Calling me
but
that.
it didn't have a name on it. I can't pull a rabbit out of my hat. So just resubmit it, okay? And I will give you credit for it. I'm not going to do this 2 weeks from now where you've got a 67 and you want to submit a bunch of late work. It's going to be those 4 famous words, Mr. Cohn, right? And they are sad, so sad.
Sir, round of applause for sir.
All right, that's it for today, folks. Any last minute comments, questions, or concerns?
Bueller.
Yo.
Eddie, I'm about to call you. Answer the
That's all,
phone.
folks. Otherwise, I will see you on Thursday. Do those
Eddie, I'm about to call you.
problems.
Answer the phone.
Ooh.
Sir, do the Looney Tunes again. Come on.
Yeah. sir.
Invest a whole 15 minutes in your Algebra 2.
Sir.
All right. Mr. Carpenter, you okay? Sounded like something was happening. All right.
Have a good one, sir.
We'll see you. Adios.